In this lesson, we're going to focus on the equation of a linear relation because in the first lesson of the unit, we focused on the graph of a linear relation. In the second lesson of the unit, we focused on the table of the linear relation. Okay, so you can tell from the graph if you have a linear relation if it's in the shape of a line. You can tell from the table if you have a linear relation if the first differences are constant. But what about the equation? If I give you an equation, how do you know you have a linear relation? So, you can tell you have a linear relation if your equation is written in the form of y equals mx plus b. If your equation is written in the form of y equals mx plus b, then you have a linear relation. Now, we want to break apart this equation into its four components. What is y? What is m? What is x? What is b? So let's start with y and x. Those are our variables. So y is the dependent variable. X is the independent variable. Okay, so in some of the word problems that we'll be doing later on, you won't have y and x. Okay, it'll be like, I don't know, let's say instead of y will be c, and instead of x it'll be n. But it's the same idea. It's different letters or different variables representing your independent variable and representing your dependent variable. But we always put the dependent variable by itself. So in this case, it's y equals. And then the right-hand side of the equation will be taking your independent variable and multiplying by this number plus this constant. So what is m and what is b? So m is our rate of change. Okay? And remember, rate of change can be found by finding the rise and finding the run and dividing them. So rate of change is rise over run. And what about b? B is our vertical intercept. Or you can say it's our initial value. Okay. So we usually talk about the vertical intercept when we talk about the graph, and we talk about initial value when we're given like a word problem. Okay. So we're gonna talk more about vertical intercept and initial value later, but I want you to take a look at this equation and understand all you need in order to write the equation of the line is you need two things: the rate of change and the vertical intercept. Rate of change, vertical intercept. Once you can establish those two things, you can basically fill in the blanks and write the equation of your linear relation. Okay, and as you'll find later on, the equation of a linear relation is very, very powerful. It can help us answer many of the word problems. So one more time, to state the equation of a linear relation, you just need to answer two questions. What's the rate of change? What's the vertical intercept? And luckily, it's not that hard to find. So I'm going to start off by giving you a graph here of a linear relation. I have the graph, but I want to write the corresponding equation of this linear relation. So once again, I need two things. I need the rate of change and I need the vertical intercept. So I'm going to start off by talk about the rate of change. Let's find the rate of change. I just need 2 points. I need 2 points that are very clean. It's where the grid lines intersect. So you could choose two totally different points than I choose, but I don't know, I feel like this one's really nice and this one's really nice. Okay, so connect them and then draw a right triangle, and then I can find the rise and the run, right? Rate of change is rise over run. So what is the rise? The rise, hopefully you can see, is 2 and the run is 1. Hey, 2 over 1, that's just 2. The rate of change for this linear relation is 2. Bam, halfway there. I need two things. I need the rate of change and the vertical intercept. Well, wait a second. What is the vertical intercept? The vertical intercept, and you can basically come up, read the name and come up with this, It's where the line intercepts or intersects with the vertical axis. Okay, and that occurs right here for this line. So where does it intersect with the vertical axis? At -2. -2. So B is equal to -2. Mission accomplished. I got the rate of change, I got the vertical intercept. So y equals 2x minus 2. That's it. I just need to find those two things and I'm done. Rate of change, vertical intercept. Alright, let's go over here. Same idea. But this time I'm actually going to start with the vertical intercept. Right there. Okay, so B is equal to 5. Halfway there. Halfway there. So now I'm going to pick 2 points. You know what? I'm going to choose this one. So the rate of change is equal to rise over run. What's the rise? Ooh, be careful. Please don't put 3 over run as your rise and your run. Okay, I think it's a very common mistake. A lot of students put 3 over 1, which is 3. So hopefully you can identify the mistake. The rise is -3, right? And -3 is your rise over run, your rate of change. So as you can tell from this line, if it basically rises to the left, okay, then your rate of change is negative. And if the line is rising to the right, your rate of change is positive. But really, if you don't have to memorize that rule, just look at the 2 points, right? You have to go down and to the right. As opposed to on the first example, you went up. Okay, you went right and up. Okay, so back to the question. I have the rate of change. I have the vertical intercept. Let's write the equation. Y equals -3x plus 5. Beautiful, right? So you always want to find two things. If you're asked to find the equation of the linear relation, you need to find the rate of change and the vertical intercept. Okay, let's look at this question for C. You don't have to do this, but I'm going to find the first differences. 2, 2, 2, 2. Beautiful. So this is very good. The first differences are constant, which is what I expected. Because otherwise, I can't write the equation of a linear relation if it's not even a linear relation. So now I've confirmed it is indeed a linear relation. But the reason why I found the first differences is to show you that this number 2 here is very special. This is our, you can draw a point and arrow to all 4 of these values. This is our rise, right? The rise. It's how your y values are changing, right? How you're going up or down. So in this case, you're going up. And what about these values? How are the x values changing? You're going adding 1, adding 1, adding 1, adding 1. So these numbers are our run. So the rate of change is equal to rise over run once again. In this case, it's 2 over 1, which is 2. Okay, halfway there. Remember, you need two things. Rate of change, vertical intercept. What is the vertical intercept? Well, you have 5 points. One of them is actually the vertical intercept. Hopefully you can agree that this point, 0, 11, that is going to give us our vertical intercept. Okay, the vertical intercept is 11. In fact, whenever your independent variable is 0, that point will correspond to the vertical intercept. Because guess what? If your independent variable is 0, you're going to be plotted, the point would be plotted on the vertical axis. So anyways, if you have a very hard time accepting that 0, 11 is on the vertical axis, then just plot it. See, 0, 11 right there. Okay, clearly that is our vertical intercept. Okay, so I have the rate of change, I have the vertical intercept, so y equals 2x plus 11. One more. So let's find the first difference is because that's going to give us our rise. Negative 6, negative 6, negative 6, negative 6. Beautiful. So these values are our rise. How about these values? How are the x values changing? Plus 2, plus 2, plus 2, plus 2. So you know what? I think I know what the rise and the run is now. The rise is negative 6, and the run is 2, which means the rate of change is negative 3. And then of these 5 points, this is the point that is on the vertical axis, which means the vertical intercept is negative 1. And like I said, if you're having a hard time, what you can even do is just plot all 5 points, and you'll see that 0, negative 1 is our vertical intercept. So the b must be equal to negative 1. So our equation is y equals negative 3x minus 1. Okay, so in summary, you need to remember y equals mx plus b. M is the rate of change, and b is our vertical intercept. Once you establish what those two values are, you can write the equation. Okay, now it might require you to do some math, but that's not a problem. Okay, just remember rate of change is rise over run. Now with the vertical intercept, usually you can just read it from the graph and from the table.